Hey everyone, welcome back to Mathematical Learning. Today we're gonna be talking about a problem. So it's kind of like a 3D Pythagorean theorem. So consider a tetrahedron, and this triangle is a right angle triangle, this triangle is a right angle triangle, this triangle is a right angle triangle, and there's also the slopey face at the front, which you can kind of imagine. So what we want to prove is if we let this side be P, Q, R, and the front side be S, we want to prove that P squared plus Q squared plus R squared is equal to S squared. Alright, so let's start on this problem. Let's let this side be A, this side be B, this side be C, and we draw the tetrahedron. Let me make it a bit clearer. C, this is B, and A. So now we're gonna find out the sides of this slopey face. Well, obviously, I think I'm gonna draw this better. A, so A, B, C, and well, the three sides of this slopey face are, using the Pythagorean theorem, square root of A squared plus B squared, square root of A squared plus C squared, and root B squared plus C squared. So these are the sides, and we are going to use the cosine rule to help us find the area of this face. Alright, so let's use the cosine rule. Cosine rule states that for triangle with sides C, A, B, and theta. So these are not necessarily the same C, A, and B I mentioned earlier. These are just some arbitrary sides. The cosine rule states that C squared is equal to A squared plus B squared minus 2AB cosine of theta. So we're going to be using this. So let's make a note. Let's make a note of our sides. We have got root A squared plus C squared, square root of A squared plus B squared, and square root of B squared plus C squared. And we're just gonna let this we're just gonna find out the theta between these two sides, and just picking two random sides. It could be other sides and you still get the same result. We're gonna use this. So let this be C, or I'm not gonna call it C, I'm gonna call it maybe big C, big B, and big A. So by the cosine rule, A squared plus C squared is equal to A squared plus, well, this squared is equal to A squared plus B squared plus C squared is A squared plus 2B squared plus C squared minus 2AB, minus 2 square root A squared plus B squared plus C squared cosine of theta. Okay, so it's getting a bit messy. I'll just erase it. And notice we can cancel this out. So we have 0 equals 2b squared minus 2 square root of A squared plus b squared plus c squared cos theta. And we're going to just divide by 2 on both sides, and we are going to add this guy on both sides, and we get b squared is equal to the square root of a squared plus b squared plus c squared, and cosine theta. And I'm gonna divide on both sides. We have cosine theta is equal to b. Actually, I'm gonna divide and square b to the 4th over a squared plus b squared, b squared plus c squared. So this is gonna be cosine squared theta. We can also write this as 1 minus sine squared theta, and we can do 1 minus on, so we have sine squared theta equals, well, this is 1 minus this thing over here, which is also equal to a squared, this thing minus b fourth over, well, this thing over this, let's call it x. So we have x minus b fourth over x, and now we're gonna take the square root on both sides, and we're gonna get sine of theta. Okay, now sine of theta. Sine of theta equals square root. Now, x is, well, we can expand it out now. It's equal to a squared b squared on the top, because we're subtracting the b fourth, plus a squared c squared, all over a squared plus b squared plus c squared. And if you expand this out, you'll see it's just this thing plus a b fourth, and you might remember we subtracted the b fourth earlier, so it all works out. Okay, so now what we can do is note that using the surds formulae, we have, if this is equal to the a squared b squared plus b squared c squared plus a squared c squared, all over square root of a squared plus b squared plus c squared. And you might remember that this is actually equal to a times b, and this is going to help us because one of the formulas for area is half a b sine theta, so we can multiply by ab on both sides, and we get and we can multiply by half as well. Half ab sine theta is equal to the square root of a squared b squared plus a squared c squared plus b squared c squared, and this is equal to the area. Oh, sorry, we have to add the half. this is actually equal to the area of S. So we can say S, and we can square both sides. S is equal to 1/4 A squared B squared plus B squared C squared plus A squared C squared. And notice that this is equal to AB squared plus BC squared plus AC squared. And quarter is just a half squared. We can distribute, and we get 1/4 AB plus 1/4 BC is equal to 1/4 AC. And we can simplify this to half a S squared is equal to half AB squared plus half BC squared plus half AC squared. And actually, by way we define AB, this is actually equal to, remember, AB, this is actually equal to P, this is equal to Q, this is equal to R, and so we have P squared, so we have P squared plus Q squared plus R squared is equal to S squared. And we're done.